So I'm going to talk a little bit about the experience of planning and hosting the IEEE Brain Data Competition at Charles River Analytics. So it was this time last year when Narissa approached me and told me about the IEEE Brain Data Bank Challenge and the international effort, and she asked if I'd be interested in taking on the Boston competition, and I leapt at the opportunity. I thought it was, it would be a lot of fun to bring it to Boston and a topic that I was really interested in. But in addition to the hackathon component, I also thought this was a really interesting opportunity to actually bring people together from different industries, different groups, academia, government, industry, who don't ordinarily get a chance to interact. A lot of these groups work on similar projects, but they're often siloed, and there's really not a lot of cross-interaction, especially in academia, where they may get funding from government or industry, but they really don't necessarily have an idea of sort of what's going on behind the curtain. So being an individual who came out of academia, who went into industry, and works very closely with the government, I saw this as a really good opportunity to actually get these people to talk together and interact. So I'll review the planning process, which took the better part of a year. So including teaming, actually getting people together to help organize the event, acquiring a data set, and planning the competition. I'll discuss sort of what happened on the day of the competition and some future directions and lessons learned that I think we can bring into the future as we continue to host these events. So in terms of teaming, I reached out to two colleagues that were in academia. Basically, this event couldn't have happened if we didn't have really strong support from academics. So Dr. Sam Makalka from Olin College. So Olin College, if you've never heard of it, it's a small engineering school right outside of Boston. It's extremely focused on engineering and training engineers who are focused on learning and the problems and really creative students. So I wanted to get her involved. Basically, she's really interested in education. Her background is in neuroscience, and this gave us an opportunity to bring the program into the classroom. Also working with Dr. Wasim Malik, who's at MIT and Harvard and MGH. We worked with professional organizations, IEEE, of course, and Narissa, Sanquan, and Grace Rigdon were really pivotal in helping organize the event. We reached out to government, so IARPA. If you never heard of IARPA, it's the Intelligence Advanced Research Project Activity. It's similar to DARPA, if you've ever heard of that, so within the Defense Department, as well as industry, so Charles River being that industry partner. The most difficult part of this entire process was actually acquiring a data set. And I think a number of people have mentioned that it's critical to get good data and large and interesting data sets. So being in industry, we knew government partners, and IARPA in 2013 or so, they funded about a $30 million project called SHARP, so Strengthening Human Adaptive Reasoning and Problem Solving. So this was a really large effort to basically determine, can we enhance intelligence in high-functioning individuals? So in this project, the details aren't so important, but 3 industry partners were selected to perform. Charles River Analytics was one of them, Honeywell, and University of Illinois, Urbana-Champaign was one of the teams selected as well. So with this data set having to do with brains, we knew it's a really rich data set and a longitudinal data set. We approached IARPA, asked if they'd be interested in working with us and potentially providing data. So we finally selected on the data set that was put together by University of Illinois. They basically had a really large, clean data set, and really more importantly, they were really enthusiastic about being involved with the developing and planning the actual event with us. So in total, the data is pretty large. It was about 11.5 gigabytes. and we hosted in the IEEE data port. Overall, I think that was really successful. People, for the most part, were able to access, download data really without difficulty. The data set was collected from 25 participants that trained on adaptive training tasks, so including visual spatial tasks and to change detection tasks. And people trained for, in this project, 16 weeks, 3 sessions per week for 48 sessions. The details don't really matter. The point is we had a lot of rich data set, or a lot of rich data. And in addition to the actual training data, we had pre and post data. So people basically took cognitive tests pre and post. We had all the training data, and we also had a really rich set of imaging data. So we had structural MRI scans. So if you've ever seen an MRI, it's that black and white scan, that basically just the flat image. We had fMRI, so functional magnetic resonance imaging data. So what brain areas were active during different tasks. And we also had diffusion tensor imaging data. So we had this information about different brain regions and how richly they're connected to other regions. So without getting into too much detail, I think it's important to note that without much pre-processing, you're able to get a really rich sense of what the data looks like. So you can get training data for individuals. With a little bit more pre-processing, you're able to get clustering data, and then that's from the imaging data. So we had behavioral, demographic, and imaging data for people to work with. The next step, so now that we had the team, now that, or the organizing team, the data set, the next step was to actually plan the competition. So the purpose of the competition, we want to bring together people from different backgrounds, neuroscience, data science, biology, computer science, to come together and work on an interesting data set and see what could they find. But again, more importantly, bring people from different backgrounds under one roof for an interesting project. We had 3 cash awards, so totaling $1,500. This was, we found this was key to bring people in the door. So we tried to raise the award amount to make it attractive. The presentation, 5 and 5. So we had 5-minute presentations and 5 slides. And overall, we didn't really give that much more direction. We wanted to leave it pretty open to people. And the judging criteria, so we're looking at data analysis, what creative approaches did people take to analyzing the data? There's a large, rich, multimodal data set. What approaches did they take? Again, without a lot of direction from the organizers. The visualization, they're able to analyze the data, but can they actually present the data in a meaningful way? Finally, presentation and interpretation. So again, this was an open data competition. Are they actually able to present the data in an interesting way? And were they able to interpret the results in a meaningful way? Because we didn't have very specific criteria for judging, we weren't looking, how well can people predict something from another thing. We basically provided a number of different challenge questions. None of these had to be specifically addressed, but this was just to get participants thinking about, what were we thinking, what direction what approach were we taking in how we want to interpret the data. So for example, does intervention training predict changes in pre and post intervention performance? It's a pretty simple question. You can answer that in a number of ways. So finally, the actual day of the event. This was December 9th. The day of the event, I think there was actually a snowstorm. So we
it's not yellow and red.
Yeah, so this was not taken the day of. But despite having a snowstorm, we had a fairly strong showing. I think we had 35 plus people. So actually planning the day, we took an approach where we basically wanted to organize a symposium around the data competition. So in the morning, we had a number of keynote speakers, including Dr. Jeanette from IARPA. She's the program manager in the SHARP data that I presented earlier. We had Evan Anderson from University of Illinois, who really helped and worked very closely with us to curate the data. So he presented a little bit more background on the data and what the experiments looked like on their end. We actually had the competition presentations, so we provided a real solid hour for that. We wanted to give people time, not only to present, but also to network. Sam Bakalka, again from Olin College, she described how she brought in the data set into her classroom. So she's a professor at Olin. One of the courses she teaches is brain technology or neurotechnology. And she utilized the data from the competition as an actual module in her class, and used that to within her class to basically train people or teach people how do you take an open data set, without a lot of information, and basically how do you tackle this data to do something meaningful with it. And finally, we had a number of presentations at the end of the day. So Alec Widge and Tim Wagner. That actually, it turned out to be an interesting set of talks because Dr. Widge described some of the work he's doing in invasive neurostimulation, and Dr. Wagner balanced that with extracranial neurostimulation research that he's doing. The judges we had, so we had Alexis Jeanette, Alec Widge, and the president of Charles River Analytics, Karen Harper. So we had a real nice guest panel of judges. In total, we had 5 different teams. These were a really diverse set of teams. Not everyone was from neuroscience. So the approaches that they actually took were really interesting. And it was really exciting to see what these teams brought to the table. And they were everything from first year postdoc or first year graduate students to postdocs, and I believe we may have had a few undergrads as well. So achieving that goal of getting a diverse panel of participants. So the actual presentations, I was blown away by the presentations. They were really high quality and really creative analyses and presentations. So this is a few screens from the winning team. They brought 2 different approaches, so graph analysis, basically how do different clusters relate to other clusters in the brain. But I think what won this team over was they had a really interesting analysis. It was relating brain size to training effect. So what they found in the results is people with brain sizes that were larger than average or smaller than average did not benefit or got worse from intervention training. And the people with average sized brains, so this is looking at the brain volume, had an improvement in intervention training. And I think why people really like this is, at face value, this makes no sense. And it probably, is not correct. But this is what this is what the results said, and they presented it in a really creative and convincing way. And I think that was, really one of the main purposes of the competition. So in total, we had our 3 winners. So we had a team, I think, from Massachusetts General Hospital, MIT, and Georgia Tech and Charles River. In conclusion, I had a lot of fun planning and organizing this event, and I think it was actually really successful. One of the main reasons why I think it was successful is I think this provided a great model to bring into the future. So the government funds a lot of really big data projects. And oftentimes this data, when the project's done, there's not funding to explore the data, to present the data, to report the data. So a lot of times, a lot of really, really rich data sits on the shelf. And there's really no mechanism to bring that data off the shelf and analyze it in a fun and interesting way. So I think this model, or this brain competition actually provides a model for that. It opens up data that's sitting on the shelf, really high quality data that's been collected in these government projects. And it enables students to analyze the data. And if they find interesting things, awesome, we discovered something new. If they don't, that's okay. You've had these student groups that have had some experience working on interesting and real data. So moving into the future, these data competitions are a really cheap, easy, great way to analyze data and to get developing students a lot of experience. So, feel free to reach out. Happy to answer any questions or continue the conversation. And thank you.